Hi, in this video I'm going to make a 3D scan of this plastic cover for the seat belt. So if you lost one of this, then you can scan the one from the other side and then mirror it in a CAD software or in your slicer, and then you can 3D print this cover. This one has 4 clips. The shape looks simple, but we'll see if it's easy enough for reversing, or if it looks simple, maybe it's not simple to reverse. So this 2 clip we go to here. These 2 clips here in the bottom we go to here. So we have 4 clips and 4 slots. For scanning the plastic cover like this, you should always scan the mounting point, which is very important because you want to know if you can adjust the clip so that it will easier to print. Okay, this should be enough. Start the scan with the Raptor X. Okay. It's a thin shell, 2 or 2.5 millimeters in the thickness, and it created by using a different plane. This side is not straight line. Inside it has 2 push pin and 2 clips. Push pin will be pulled in this direction. So when I align the model in the slicer, the wall line has to be parallel to the force that pull or push it, so it won't break easily. And this push pin is very stiff. It has a groove, but it actually not moving. Okay, so it also has 3 small stiffener. I will use the Creality Scan Rapid Pro for making this scan. The part is quite small, so I use external marker. And then I will scan in 2 sides, top side and the bottom side, and then I merge them in the Creality scan. This is the fastest way, and I will not use the spray. I use the pyramid to lace up the object from the turntable so that I can easily remove it later. Okay, I will use 0.25 millimeter for the resolution, and then I start by scanning the marker using the global marker scanning, and I click on the automatic exposure. Okay, I have about 113 markers. Okay, I switch to 7 line. Okay, it's done. Here's a second scan, 0.25 automatic exposure global marker. Okay, let's start with the cross line. Okay, it's done. .25. Okay, here's from the first scan, almost 300,000 points. Okay, let's process the background. Okay, let's merge this one together. scan 1 and scan 2. I align them. 1, 2, 3. Start it. Okay. Click yes. Exit merging. Okay, now it's merged. We have a 525,000 point. And then I will export this as a ASC format. Let's move to Cloud Compare. Okay, next I will align the 3D scan of the plastic cover and here the scan of the mounting point. Okay, now I have a proper aligned point clouds, the mounting point and a plastic trim cover. As you can see here, I cannot increase the thickness of the shell. It is flush with the mounting point. So if I increase the thickness, it will affect the fitting. And I have some area here closer to the stiffener area that I can use a thicker wall from here to the bottom here. I can increase the thickness of the wall. And the spacing to the belt, the seat belt, is not much. So I cannot change anything along here. It has a raised edge along this part that will clash with the mounting point. So I need to exactly clone this part. So using point cloud for reverse engineering is like you have an X-ray frame. You need to inspect the mounting point and the part that you are going to reverse when it put together. Okay, next I will export this in the LAS format, and then I will convert it to the RCP files using Autodesk Recap. Okay, here's in the AutoDesk Inventor. I import the point cloud from the Cloud Compare. It has already been aligned to the XY plane. Next step, I'm going to turn off the car side. I'm going to create a plane. See here, this plane. By using this point, so I snap one of the point to the bottom face of the scan. With this plane, I create a sketch, drawing a box larger than the object. And then I'm going to extrude it just a little bit taller than the point cloud. Okay, next step, I'm going to create a plane by using 3 points. 1, 2, and 3. This 3 point is snapped onto the point cloud. I use a sketch to cut on the first side of the box. I do the same on this side using 3 points. And the sketch here is a little bit larger than the profiles of the box. Then I cut it. See, I cut it like so. The fourth cut on this side, I do the same. I make a plane using 3 points. 1, 2, and 3. I select the point manually because I want to choose the correct plane to cut it. Okay, this will be the fourth cut. Then I cut it. Okay, here's the final cut. I make 3 points. 1, 2, and 3. And the 3 corners, I create a plane. And then I create this sketch to cut it. So I have a box that has a wall that matching the plastic cover. So next will be easy. I create the first fillet by just moving the mouse to match the profiles of the point cloud. So that will be the first fillet corner. And this will be my second fillet. So I use the point cloud. So I use the point cloud to align. I only use extrude command and the shell command. So there is only 2 commands. You can probably use any CAD software to draw this, even with a free CAD. So shell command will allow me to remove faces. So I remove the top face and 2 of the side face, and I apply 2.4 millimeter for the thickness. So I use a point cloud as a reference for the thickness. So the entire process, even with the thickness, I didn't use a vernier caliper to measure any part of the 3D scan, only rely on the point cloud dimension. So here I have a first shell command executed. Okay, and next I'm going to create a sketch to make a cutout on this wall. When I create a sketch, I will simply trace it. You see the point cloud here. I simply use the line. I will usually draw a line longer than I have to, and then I will move it, to align it, and then I use extrude command to cut it, and then I use a fillet command to fillet the corner by using the point cloud as a reference. Just move my mouse until it's aligned with the point cloud. And one small fillet here on the corner. Next, I make a cut on this side of the wall, this corner. So I do the same. I use the line, draw it longer, and then I align it to the point cloud like this. You can zoom in and move very close. And then I make a cut using extrude command. And then I use a fillet command. Okay, I do the same here using the fillet command. Okay, next I'm going to create a sketch. This line, I trace it along the point cloud to create a stiffened edge. On this side of the wall, it has a raised edge for stiffen. And then I extrude it like this. Instead of making a stiffener like the original part, I decide to thicken the wall just in this area. I make a cross-section profile using the plane cutting, and I draw this sketch. See, I extrude it from here to here so that I don't need support when I print this. Okay, next I'm going to make push pin. First I create a sketch like a small square, and then I extrude it. I extrude it like this, and then I create the first sketch by tracing along the point cloud to cut the first profile for the push pin. This is the first profile, and here's a second profile. See here, I trace it along the point cloud. Okay, here's second cut, and now I have a complete first push pin. I cannot mirror the push pin from the other side because this side of the push pin is not the same. It was attached to the curved wall, so I need to do this pin separately. I do the same thing, extrude the box, and then the second cut. So next I'm going to create a cut here so that the stiffened part will not interfere with the mounting point. So this mounting point is very close to the stiffener area. Okay, next to make a third clip, I create a box like this, and then I cut the profiles using the point cloud as a reference. And the second cut, and then I fillet the corner. And I do the same with the second clip, which is I cannot use the array command. It was sit near the curved surface, so I need to draw it separately. I do the same thing. Make an extrusion, second extrusion for the cutting the profile, and third extrusion, and I fillet this part to blend in. That will be the final cut for the clips, and I add the chamfer edge here just in case that I want to print it in a different orientation. So now it's complete, all the part, and next I'm going to export this as an STL file and put it in the slicer. Okay, let's drop the files to the print bed. Okay, now I have to consider the orientation on the print bed. If I print it like this, it's going to create an issue with the transition from the flat plane. See here, the flat plane to the fillet. When it starts to curve up, it's going to create a line. There's some sharp edge instead of a smooth transition on this side as well. It doesn't look good at all. It cannot generate a tree support from the print bed. If I click here on build plate only, and then I slice it, see here, the support plane is too short from the print bed, so it cannot create a support for the clips. So this orientation is a no-go. If it builds the support directly on the print face, the support will fail because see here, it's one layer floating on the finished surface. The support will not adhere to the print face. The best orientation is to print it in a vertical direction with this face. I'm gonna choose this one. See here, I'm gonna choose this orientation because the tree support can be built from build plate and go up to support the clips and the face here on the top face. So if I click on slice, see here, tree support can be built because it's tall enough. See here, all the clips can be support. Even though the printing time is twice, now it's 2 hours. But if you look at the surface, quite smooth, because it's print in this direction. If we give a smooth curve, I probably don't even have to do sanding after printing. So it will be a little rough here on the top. Okay, I send it for printing. and the support is 31% of the printing materials. Okay, looks like all the support is working, and it should be easy to remove. Try this. Oh, that's very easy. The surface here is already rough near the support area. The outside, it looks smooth. Let me sand it. Okay, let's do test fitting. Oh, fudge. That's a biscuit. How long it's been there? Okay, let's remove it. See if the push pin will break. Yeah, it's still holding. Nothing breaks. So it's fit tight and it won't break because I printed in the correct direction. Okay, let's take a closer look and compare with the original part. I think the outside look very nice. There's some layer lines here on the top. I think it still look nice. Yeah, some layer line here on the top. I sand out this side that sit on the support. The surface is quite rough, so I sand out, and also sand out this area as well. I try to push in and out a couple of times, and the clip is still holding. It's no breaking. Yeah, I think this 3D scan, reverse, and 3D print work well with the plastic part of the car interior, because most of the car interior, the plastic part is thin shell, and if you can make a 3D scan and reverse it in CAD, then you can modify some part, make it more suitable for FDM printing. Yeah, I mean, a 3D printer this day is a lot easier to print with. Before this, 4 or 5 years ago, I can't even stick the ABS filament to the print bed. It just fall out. Now with the enclosed printer, and now they have a better support, like this 3 support. It's very easy to remove. I can place the model in a proper orientation so that it will give a smooth surface even with the large fillet curve like this. Okay, thanks guys for watching. I'll see you in the next video.